Series on mobile application design and development. In part 1, we are discussing about the Kotlin introduction. In part 2, we are discussing about data types and variables in Kotlin app. In data types, the data types are categorized into various groups in Kotlin. First one is number, characters, boolean, strings, and arrays. In numbers there are two categories exist from different number types. Whole numbers, whether positive or negative, like 123 to 4 minus 446, are stored as an integer type with digits. These types byte numbers should be stored in types byte, short, int, and long or acceptable. Floating point numbers are fractional numbers that include one or more decimal. The two varieties are double and float. Here you can see that integer type. Integer type can be byte, short, int, and long. In byte, whole numbers between minus 128 to and 127 can be stored in the byte data type. Here you can see that example declaration and declaration and initialization byte with the example, and short between minus 3,270,768 and 32,767. Full numbers can be stored in the short data type. You can see that initialization and declaration, and int numbers can be stored in these digits. Entire numbers can be stored in the int data. Here you can see the example. In long whole numbers between in this range we can in between the range we can store in the long data type. In long data type, when it int is too small to hold the value that is utilized to long, but when we use long data type, we have to mention small or capital L to the value. And next one is floating point. Floating point types are used to represent decimal numbers like points. Like you can see the here example, fractional numbers can be stored in the float and double data types. The number of digits that can flow the decimal points in a floating points value is indicated by the bytes precision. Double variable contain roughly 15 decimal places of precision compared to the merely 6 or 7 for float variables. For the majority of computation, it is therefore safer to utilize double. Keep in mind that f should be used to terminate float types of values. Example for double here, declaration and initialization. And for float, you can see the declaration and initialization. And you can see the Boolean types. The only possible value for Boolean data types are true or false. The main application of Boolean value is in conditional testing, which is converted to the greater details in later chapter. Here you can see the examples of true or false and character. A single character can be stored using the char data type, single quotation marks a or must around a char value. Or char values are stored in mainly in single quotes. Here strings. Strings but may stored in the double quotes enclosing the string values, and arrays as an alternative to declaring distinct variables for each value. Arrays can be hold many values in a single variable. There are few main ways to Kotlin handle the data types differently than the other languages. Main reasons. Main reasons Kotlin handle the data types differently than other languages. First one is null safety. Kotlin guards against mistakes by ensuring that variables cannot become nulls unless they are specially marked as such. By doing this, typically null pointer exception in other languages are avoided. And second one is type interference. Kotlin has the ability to infer a variable type automatically, saving you from always having it to specify. As a result, that code is simpler and less interruption. Immutable type. Kotlin encourages the use of immutable variables with the val by default. These variables are unchangeable after they are assigned writer shift and more dependable code aided by this. Dat- Data class. Kotlin data classes make it easier to create classes that just hold data by automatically generating methods like equals and strings. And seal classes. Seal classes make it possible to limit class hierarchies to a predetermined set of types, which promotes safer type managed and verification. Type alias. Kotlin enables you to define substitute names for pre-existing types, which facilitate the understanding the manipulation of complex. Here you can see the variables difference between. Here you can see the difference between val and var. For a variable whose value is constant, use val. Once a variable has been declared using val, you are unable to remove or change the number that is inside the box once you enter number, similar to writing anything down in open. It's finally an immutable. Example for val. Immutable variables cannot be reassigned. And var. For a variable whose value is changeable, use var. However, employing a changeable box referred to as a var in code is equivalent to using pencil in a place of pen. You can enter a number. If you don't like, we can change it or we can remove this number. Mutable variables can be reassigned. That's why we call it var as a changeable box, and immutable variables cannot be reassigned. That's why we call it val as a permanent box.